Hello everyone, we are from Group Mayday. Today we would like to present normal density and discrimination function. In this video, we will explain about normal density, univariate density, multivariate density, discriminant function and some example case. First, it is important to understand that normal density describes the probability distribution of continuous random variables that are symmetrically distributed around the mean. There are two types of normal density that are widely used, which are the univariate normal density and the multivariate normal density. These distributions are popular because they are mathematically and analytically tractable, which means that they are easy to work with when performing calculations such as computing the expectation. Next, let's take a closer look at the univariate normal distribution. This is the formula for the univariate density where the mu is the mean order expected value of x and the square of sigma is the variance order expected square deviation. Besides, we use the following notation to indicate that the variable x follows a normal distribution with the mean and variance. In a normal distribution, the data points tend to cluster around the mean. This means that the value near the mean that are more likely to occur, while the value further from the mean become increasingly less likely. While the standard deviation determines the spread of the distribution, a smaller standard deviation means that the values are tightly grouped around the mean. A larger standard deviation means that the values are more spread out, which indicate more variability in the data.
Hello, I'm Chujin Yi. So now I will continue the multivariate density, where the x is the component column vector with the t stand for the transpose vector form. And the mean is the component mean vector with the sigma d multiplied with d covalence matrix. The sigma have two meaning, one is the determinant and one is the inverse respectively. And now for the mean is equal to E multiplied with x, which equal to the integration of xp multiplied with x multiplied with dx. So let x be a continuous random variable with a range and probability density function px. So the expected value of x is the defined, which before that the expected value also called as the mean. So based on the formula, we can calculate the mean. This diagram shows the covariance matrix, and the covariance matrix is always symmetry with sigma ij equal to sigma ji, and it was positive semi-defined.
Hello guys, my name is Mark Hui Chin and I'll be presenting on discriminant function. So what are discriminant functions? In a simple term, a discriminant function is a rule that helps a classifier decide which class a new data point, also known as a feature vector x, belongs to. The classifier doesn't just randomly guess, it's computed a value or a score for each possible class, and this score is based on how well the data point matched that class. Then it simply picks the class with a higher score. And next, you can think of the classifier as a network or a machine that computed this score, one of each class, and select the one with the larger discriminant value. Now, why we are using discriminant function? Discriminant function is to simplify the classification process, especially in a situation involving a multivariate normal distribution. Instead of trying to manually analyze complex patterns, we let the discriminant function handle it. It will make classification quicker and more semantic. So, in short, calculate a score for each class, compare them, and assign the data point to the class with the higher score.
Hi everyone, my name is Lin Yubin. I will talk about the special case of discriminant functions. There are case 1, the sigma I equal to variance multiplied with I, and here I is stand for the identity matrix. This situation happens when the features are independent and each feature has the same variance, which means they're having the same mean. And the formula for the linear discriminant function is as shown, gi in condition of x equal to omega I power of t multiplied by x plus omega I0. And the omega I0 is the threshold or bias for the I category. And the second case is sigma I equal to sigma, which means they share the same sigma, and this situation will cause the covariance of all classes will be the same. And this show the formula for the discriminant function during this case. The third case is sigma I equal to arbitrary, which is the general case, and the equation are like below. G sub I in condition of x equal to x power of t wi multiplied by x plus wi with the power of t and multiply x, it also equal to omega I0, and you can decide which one you use if the information given is fulfilled. And in two category case, the decision surface are hyperquadratic. And there are a few examples of hyperquadrics. And the first one is hyperplane. Next one, there are hyperspheres, hyperellipsoids, and there are hyperparaboloids and hyperboloids. That's all for our presentation. Thank you for your listening.